Good morning, I'm Maithili and we are from Group 3A. My teammates are Joshna and Angel. We have worked on the project which is an efficient novel approach based on IoT for detecting attendance through RFID module and IR sensor guided by P. Gopalakrishna sir. As we know, the attendance plays a very important role in any organization. Maintaining the attendance of the students in an institution is a hefty task. Always there is a difficulty in handling attendance manually. Attendance in many organizations, colleges, and schools is still paper-based. When paper-based attendance is considered, the chances of errors are high. Using technology, this issue can be solved and the papers can be avoided in this process. There are many technologies that support to solve this issue. This project aims at designing a smart attendance system that automatically monitors and manages attendance of the students in an institution efficiently. In this era, the RFID is one of the best contactless communication system. It is nothing but the interfacing of RFID with NodeMCU. It can read the wireless data and also store it. In this research, we proposed an automatic attendance by using RFID. Existing systems, IoT-based smart attendance monitoring system using RFID. Here the RFID scanner is used to scan the RFID tag of the student. Whenever the RFID tag is scanned by the RFID scanner, it will automatically update the attendance of the student in the Google Sheets with the name, time and date. The next one is biometric attendance system using IoT. The fingerprint scanners are used for recognizing the fingerprint of an individual. The system was not safe during COVID as it required the user to get into physical contact with the sensor. So RFID is the best contactless communication system that marks the attendance of the student. In this era, RFID is one of the best contactless communication system. The main concept behind radio frequency based attendance system is to take the attendance. RFID card has to be shown in front of the RFID reader and then the attendance of the person is noted down in the microcontroller memory. RFID based attendance system is one of the solutions to address the problem of student security by increasing the system efficiency instead of photo ID card. It also helps to take the attendance of the workers at their working place. Its ability to uniquely identify each person based on their RFID tag type of ID card makes the process of allowing security access easier, faster and secure as compared to the traditional method. The aim of this project is to design an RFID technology based attendance system using NodeMCU in which the attendance of the students is automatically recorded with the help of a card. When this circuit is powered on, the RFID reader detects the ID card. It will store the data in the microcontroller. By using suitable programming, it will convert to an Excel sheet on the computer. During this process, LCD display shows the number of students entered in the classroom and it also shows the total RFID card or tag scanned by the reader. If there is any difference in the count of RFID tags and total number of students present inside the classroom, it shows that there is some proxy in the attendance. Then teacher has to manually correct the error of the attendance. Here is the activity diagram. The first one is the activity diagram of the RFID scanner and second one is the activity diagram of the IR sensor. Here the RFID scanner will first scan the RFID tag. If the user is already registered, then it will automatically save the attendance in database. If the user is not registered, then it will deny the access. The next one is IR sensor. IR sensor will wait for the person to detect. If the person is detected and if the person is entering into the room, it will increment the IR count by 1, and if the person is leaving the room, it will decrement the IR count by 1. Here is the system architecture. The IR sensors and RFID reader are connected to the microcontroller, and whenever the power supply is given, the total count is shown on the LCD and the attendance is stored and updated in the real-time database. This is a circuit where we used the RFID reader and 2 IR sensors, and here is the implementation.
First, we need to switch on the circuit. Here we are using an RFID reader that will read the RFID tag and it will update the attendance in the Google Sheets. And here we are also using two IR sensors that will keep track of the total number of students entering and leaving the classroom. So first we need to scan the RFID tag. Whenever the RFID tag is scanned, the message will be displayed on the LCD saying welcome, and it will also show the total number of tags scanned so far. So far we scanned only one card, so it shows 1. Now whenever a person enters inside the classroom, the IR sensor will activate and it says the student is entering inside the class. It will increment the count by 1, and whenever the student leaves the class, it says student is leaving, and it will decrement the count by 1. Here both the counts did not match. That means there is some proxy in the system, so teacher has to manually correct the attendance and has to check out the proxy in the attendance system.
This is the result when we scan the RFID tag. In the implementation part where we scan the RFID tag, whenever we scan the RFID tag, it will be automatically updated in the Google Sheets along with the student ID, time and date. Here is the LCD display which displays the total number of students inside the room using the IR sensors. And the conclusion is, with the use of IR sensors and counting logic, the primary goal of developing a proxy-free RFID-based attendance system was successfully accomplished. Compared to the conventional technique of taking attendance, this project has offered a convenient method. Every time someone tries to add a proxy, the system assists in detecting it and sending an alert. Additionally, it is user-friendly and serves as a global attendance system. As a result, various organizations, educational institutions, etc. can use it. Thank you.